we had already discussed the last topic of the previous chapter, which was evaporation. Thereafter, it will be my request to all of you to go through the NCERT problems. I will be giving that as an assignment also at the end of this video. You take a look into that. Wherever, in whatever problem that you have any difficulties, like the previous video also, here also you comment. I will try to interact over there. See, in the previous chapter, we had a discussion about the physical nature or the physical properties of the matter. In this chapter, we are going to discuss about the chemical properties of the matter. The topic is the matter around us pure? So, purity of the matter, that is what we are going to discuss in this particular chapter. See, there are numerous thousands and lakhs and tons of matters around us. We have to classify them. Now, classifying them on the basis of chemical properties is not a very easy task to do. So, we will try to have our inroads into those matters in this particular chapter by keeping in mind that whether they are prepared of only one type of substance, 2, 3 or more than that, and if it is being prepared by more than 2 or 3 substances, then what will be their new chemical nature? So that is what will be our key points into this particular chapter. So let us start. So let us see the classification of matter on the basis of chemical properties. It is being classified into 2 types. One is pure substances, another is mixture. So first we are going to discuss about pure substances. So let us see what are actually pure substances. If we define, it will be like the sample of the matter which is only consists of one type of substances are called pure substances. First you write it down, then I will describe. So here we are suggesting one very key point. It is consists of only one type of substances. Means what happens if you cannot separate them into 2 or more substances. That means pure substances means which is only one type of substance are present. That type of matter we are talking about, and you cannot separate them into 2 or more. So there must be some properties. There are numerous examples around us regarding the pure substances, like water, like ethyl alcohol, like so many things. Those are made up of only one type of substances. sodium chloride also. And if we need to revisit the chemical properties, it will be like properties of pure substances. First property that we are going to see is it is only made up of one type of atoms or molecules. That means, say for an example, we talk about, here I am writing separately, water, or say ethanol, or sodium chloride, or say iron. In all these cases, suppose we take sodium chloride. In sodium chloride, only the molecules of sodium chloride is present, nothing else. You must be thinking in sodium chloride there is sodium and chlorine. Sodium and Na plus and Cl minus is present. We are going to discuss that. But the molecules, once it is formed within sodium chloride, only the sodium chloride molecules are there, nothing else. In water also, water is, when it is present as water, it is not divided into H plus or OH minus. Remember, it is the intact water that we are talking about. So it is also not being divided into anything. Only water molecule is present. So it is only one type of molecules which prepares the water. Same is true for iron. In iron that we use in our daily life, only the iron atoms are present. Only one type of atom. So either atom or molecules. But it has to be only single type. This is the main thing. Next is it is homogeneous. It is homogeneous in nature. See, iron if you take, the composition is same throughout. Throughout the molecule, the composition does not change. It is iron only. Similar is the case with sodium chloride. If you take sodium chloride from anywhere, if you purchase or if you prepare it in the lab, whatever sodium chloride 5 gram, 10 gram or 5 kg, whatever you take, throughout that, only the sodium chloride will be there, number one. Number two, the composition does not change. Second is water. Water also, throughout the water, the nature will be homogeneous. That means the composition of the things will be same throughout. The hydrogen and oxygen combines in the same way to prepare the water everywhere. Third is its composition does not change with time. That means, suppose water, it is having a particular weight ratio, oxygen and hydrogen combines with each other with a particular amount of the weight, particular amount of mass also you can say, that composition will not be changing. That will remain the same even if the time changes. Fourth one is pure substances will have sharp melting point as well as boiling point. I'll provide you a chart right after this so that you can see that all these pure substances normally will have a particular melting point. The sharp melting point means, suppose we are talking about, say for an example, water. It is having a boiling point, say 100 degrees Celsius. It will remain the same 100 degrees Celsius, and the sharp boiling point, it is not from 95 to 105. It is always 100. So that is what we are talking about. So these are the properties of the pure substances. Write it down. After the properties, we are going to see the classification. Classification of pure substances. It is basically classified into two. One is elements and there is compounds. Elements, as you know, the examples are iron, copper, sodium, potassium, etc. And the compounds, you can take sodium chloride, water, whatever you write. There are say sodium bromide, K2SO4, numerous examples are there. FeSO4. Now, what are the basic differences? Remember, whenever we are talking about this, we need to remember the previous properties first of all. That all of these, whether it is elements or whether it is compounds, they are made up of only one type of substances. But then also, there we have mentioned that one type may be atoms, it may be molecules. So here you see, suppose we are talking about iron. So in iron only one type of atoms are there, that is iron atom. In the copper also there is only one type of atom which is present, that is copper atom. But in case of NaCl, Na is present, Cl is also present. That means Na plus half Cl2 gives rise to NaCl, right? But remember, once the molecule is formed, then the composition, the chemical composition of sodium and chlorine will not be present in sodium chloride, that we know. So throughout the molecule, throughout the mixture that you have, throughout the compound that you have taken, suppose you have taken 15 kg of sodium chloride, only NaCl molecules will be present, because once the atoms are converted to the molecules by any means, the molecules will have a new chemical property, and that is only present throughout the amount that you have taken. So it cannot be divided into two or more substances. You cannot, if you take sodium chloride and if you try to divide it by simple process, it will not come as sodium or chloride. Okay, it will remain as sodium chloride only. Same is true with water. Once the water is formed, it is only water molecule which is present. So it is only one type of molecule. I hope it is clear. Then, more important one regarding the syllabus, we are going to talk about mixture. A very well-known term in our day-to-day life. Mixture can be defined as, or mixture is a composition of two or more substances. So it is not only one type of molecules or atoms, there are two or more substances. And if you are talking about the classification of mixture, mainly it is being divided as homogeneous and heterogeneous mixture. Now, what is a homogeneous mixture? This term homogeneous suggests that two things. First, its composition, and secondly, its property. If you measure composition or property, if you take say 10 gram of any homogeneous mixture and if you check its composition or properties throughout, it is same throughout. Whereas in case of heterogeneous mixture, the composition and property will vary at different position or different location, you can say. That means if you take 15 gram of heterogeneous mixture and if you check its composition, it may be the case that on one part the composition is more or its physical properties, say density or something like that, will be more. Or at other position, the composition is different. Suppose A and B. Say for an example, if A and B you have mixed and you are getting X. So throughout X, suppose you have taken two different locations, 1 and 2. So here you are getting 91% A and 9% B. In another location, say at second location, you might get 60% of A and 40% of B. So the amounts are not same or the compositions are not same. And obviously A and B, if the percentage varies, so the properties will also vary accordingly, because they will have their influence. The A and B will have its influence on properties. So depending on its amount, the properties will also vary. But here that is not the case. Let us see a few examples that will clear our doubts. Say we take sodium chloride plus water. We are mixing these two. So we form NaCl solution. On the other side, let us take iron fillings. This is iron only. Plus, if you take any salt, say sodium chloride, and you are mixing it, obviously its composition will not be exactly same, even if you mix it with the best possible way. So this is an example of heterogeneous mixture, whereas this is an example of homogeneous mixture, because we know if you take less amount of sodium chloride and if you mix it in water, it will be mixed so finely and so beautifully that the composition will be same throughout. Its boiling point, melting point, density will also be same throughout, and the taste of it will also be same throughout. Now we are going to talk about the properties of mixture. Properties. The first property is that in the mixture, the components can exist in any composition. Any. Suppose you take salt and you take iron. So you can have two type of mixture, A and B. In first case, you take 95% of salt and 5% of iron. In another case, you take half and half, 50% of salt and 50% of iron. Both will be mixture of salt and iron, isn't it? So we can prepare the mixture in different composition. This is one composition, this is another composition. So in the mixture, the components can exist in any composition. There is no hard and fast rule to it. The next is at different location, its properties will change. Because, giving a very simple example, suppose you mix iron in sugar. So the particles of iron, say you take 5 gram of iron and you take 95 gram of sugar. The 5 gram of iron, do you think it will be distributed into the more amount of sugar in the uniform way? It cannot be. In some places the amount of iron will be more, in some places the amount of iron will be less. So obviously its properties are also going to change. Third point. Since the substances can keep their, or can retain rather, substances can retain their properties in mixture, so it fully depends on the composition of substances. It fully depends means its property will depend. Let me explain. We know if we are taking a mixture of A plus B plus C and we are forming X, so in X we have A, B and C as well. So suppose I take more amount of A, less amount of B and C, then the properties of X will not be same if I take all of them in equal amount. A very simple example, you take air. In air there is mostly nitrogen and oxygen and little amount of carbon dioxide. And suppose it is 77% and it is say 20% carbon dioxide and other gases. So I am suppose writing carbon dioxide, and suppose it is the rest of the percent, which is say 3%. Suppose, although carbon dioxide amount is not that much, you can take the property, you can feel it, the normal air that we have. Although again I am telling you the carbon dioxide percentage is not that much. So this is say one sample of air, that is A. If you take another sample, suppose B, suppose here nitrogen percentage is 80%, but oxygen percentage is very less, which is 10%. And say carbon dioxide percentage is little bit higher, say 10%, suppose. Do you feel that this air will give you same kind of feeling that the sample A will give? Definitely not. The oxygen amount is less. So you will feel sort of breathing, you will not be able to breathe properly. More amount of carbon dioxide, it will also keep so many difficulties over there. So what does it mean? More amount of substances of a particular type actually have its own effect on the particular mixture. In the mixture, if A, B and C, three types are present, A, B and C are having different physical as well as chemical property, and in the mixture they can keep their properties. So that is why in the mixture, depending on the amount that they are presenting, they means the substances, they will have its impact also. Like more oxygen, these properties will be different, less amount of oxygen, its property will be different. Similarly, if we go to the next point, write it down. In the next point, mixture can easily be separated into its components with components by physical method. And this last one is, while forming the mixture, form of energy such as heat, will not be, or heat, or you can say excess temperature, these will not be required. These 2 points. First you note it down. See, remember, if water can be separated into H2 plus O2, it has to be an electrolysis process. If sodium chloride, if you want to separate into Na plus Cl, means this will be half Cl2. Here also you have to give some electrolysis process, some process, chemical process. The compounds cannot be easily separated. But if you take iron and sugar and if you mix them in the same way, by some physical way, you can simply separate them. If you take sodium chloride and iron for an example, and if you mix it with water, iron will not be mixed, sodium chloride will be mixed. So if you then vaporize, then obviously only the sodium chloride filled with water can be vaporized. From there you can separate the sodium chloride. That means by physical method only you can separate the mixture, which you cannot do in case of compounds. Next is, remember, the formation of compound happens through chemical way. So heat, excess temperature, excess pressure, catalyst, these are required. But formation of mixture, you take iron and you take, say for an example, a little bit of sugar, or you take sugar and salt only. Simply mix them, they will be mixed. So there you do not have to produce an extra heat or something from outside. Any form of energy from outside is not required. So these are the properties of mixture.